Lesson 10-2, transformations of quadratic functions. So we have a couple transformations or translations. We got vertical and horizontal. The graph of g of x equaling x squared plus k is a graph of f of x equaling x squared. This is the parent function of a quadratic. The k tells us that it's a translation vertically. When k is positive, it moves up. So really your vertex is moving up. When k is negative, your vertex goes down. For horizontal translations, that's attached to your x. So that's going to be inside the parentheses where of your quadratic. So the format is x minus h squared. So that's the standard form. Is the graph of f of x equaling x squared. So again, f of x equaling x squared is the parent function. So if you have an h inside here, so if you have an x attached to the a number adding or subtracting to the x, that means it's going to be a horizontal translation. So when h is positive, in this case, it's positive, it's going to move to the right. When h is negative, and h will be negative when it looks like this, which really means it's a plus. So when you see a plus in there, just again, I would just make that like x plus h equaling 0. Subtract h on both sides. X would equal a negative h, which means it's going to go to the left. For example, we're going to describe the translation, whether it's going up or going down, left, right, and by how much. So here, this is after the x squared, so this is down 4. B, this is inside the square, so this is going, if I do x plus 2 equaling 0, subtract 2, x is to the left of 0, so that means it goes left 2. Next, here it's on the outside, so this is up 5, so that's a vertical translation going up 5. Here we have horizontal, x minus 7 equals 0, add 7 to both sides, and we have x equaling 7, which means it goes to the right 7. Next, describe the transformation in g of x equaling x minus 6 squared. So this is horizontal. So if I do x minus 6 equaling 0, add 6 to both sides, x is going to the right 6. Next, describe the translation here. For this one, you can see the graph of this as well. There are multiple ones. There's vertical and there's horizontal. So from here's the parent function. It went to the right 3, up 1. So right 3, up 1. Next, describe the translation here. It relates to the parent function, and then graph the translated function. So this x plus 6 means I go left 6. And then plus 3 means going up 3. So if I were to graph this, I would have a point at negative 6, 3. So that's where my vertex would be. And I would just choose a point. So if I chose negative 5, negative 5 plus 6 is 1. 1 squared is 1. Plus 3 is 4. So a point here and a point here. My parabola would look like that. Next, describe this translation. So it goes to the left 3 because of that part, and then it goes down 5. So I take my vertex from 0, 0, I go left 3, down 5, put a point here, and then I choose a point on each side, or just choose one point. So if I chose, let's just choose negative 2. If I put negative 2 in, negative 2 plus 3 is 1. 1 squared is 1. 1 minus 5 is 4. Start a point here and a point here. Draw my parabola, and it opens upward there. Next is looking at dilations. So dilations is the coefficient in front of our x squared. So in our format, so when a is attached to the x with no parentheses, this is a stretch, or it's a vertical stretch or a compression. When a is positive, or great, no, not positive, when a is greater than 1, the absolute value of a is greater than 1, it's a stretch vertically because it's going away from the x-axis. If a is between 0 and 1, it's compressed vertically. And it's compressed vertically towards the x-axis. When a is inside the parentheses, that means it's affecting the x-coordinates. And the absolute value of a is greater than 1, it's compressed horizontally. And then if it's between 0 and 1, the absolute value is then horizontally. So just remember, a stretch horizontally is like the compressed vertically. And a compressed horizontally is seen as a stretch vertically. So here, so when a, this would be vertical. When a is in parentheses, then this would be horizontal. So this would be vertical. And absolute value of 3 is 3, which is greater than 1. So this would be a vertical stretch. And we would say by a factor of 3. This one, it's in the parentheses, so it's attached to the x. So this is horizontal. It's the absolute value is less than 1 but greater than 0. So this would be go up 1 over 2. So this is a horizontal stretch. And by factor of 1/2. Next, we're going to describe the dilation and then graph it. So here it's not with the x because there's no parentheses. So this would be a vertical dilation. 2/5, that means it's less than 1. This would be a compression. So if I were to graph this one, normally my vertex is at 0, 0. And then if I put a 1 in there, 1 for x, 1 squared is 1 times 2/5, give us 2/5. So 1 and 2/5 would be roughly here, and mirror that one. So it'd be just roughly looking like here. So it's a little bit wider, it's just pressing it, vertically pressing it downward. Next, it's in the parentheses, so this is horizontal. Less than 1, the absolute value of 1/3 is 1/3, which is less than 1. So this would be a vertical or a horizontal stretch. So again, vertex is at 0, 0. If I put a 1 in for x, 1 times 1/3 is 1/3. 1/3 squared is 1/9. So that would be over here. So it's really going to look like really wide this way. So I'm just stretching it horizontally. Next is the reflections. Anytime they're talking about reflections, there's a negative involved with it. So the graph of negative f of x, reflection of the graph of f of x equaling x squared across the x-axis. So if the negative is on the outside of the parentheses, it's reflected across the x-axis because your y's are changing from positive to now negative. When negative is on the inside, it's reflected across the y-axis because now your x's are changing from positive to negative. So here we need to describe how the graph of the function changes from the parent function. So there's a negative and it's on the outside, so this is a reflection. And it affects the y-axis, affects the y-coordinates, so this will be reflected across x-axis. This is a vertical vertical dilation. The absolute value of negative 2/3 is 2/3, which is less than 1. For vertical, this would be a vertical compression. Next one, the negative and the 3 is inside, so this is horizontal. And this is a horizontal compression. The negative, so this is a reflection. It's on the inside, so it reflects over the y-axis. So it affects our x-coordinate. Next, we're going to describe the function, how it changes here, and then graph it. So there's no parentheses, so it is reflected over x-axis, affects the y, and it's a vertical change, a vertical dilation. Absolute value of -2 is 2, so this is a vertical stretch. So now the vertex is at 0, 0. If I put a 1 in for x, 1 squared is 1 times -2 is -2, so 1, -2 would be here. Mirror that one, it's going to open downward. Next, describe this one. It's in parentheses, so this is horizontal. Absolute value of -3/4 is 3/4, which is less than 1. So this would be a horizontal stretch. And it's reflected inside the parentheses, so it's reflected over the y-axis. So now a point is at, a vertex is at 0, 0. If I put a 1 in for x, 1 times -3/4 is -3/4 squared. That gives us 9/16. 9 divided by 16 is 0.56. So that would be here and over here. So that's what our graph will look like. Example 4. Describe how the graph of g of x equaling -3/5 x squared is related to the graph of the parent function. So there's no parentheses, so there is a reflection over x-axis. The absolute value of 3/4 or 3/5 is 3/5. This is vertical, no parentheses, and this will be a vertical compression. And our last parts for today is looking at transformations of quadratic functions when you're looking at vertex form. Vertex form is just another way of writing a quadratic where the form is giving you the vertex in there. So the h is your x-coordinate, y is your y, and k is your y-coordinate. So each constant in the equation affects the parent function. So the value of absolute value of a stretches or compresses the parent function. And when the value of a is negative, the graph is reflected across the x-axis. The value of k shifts the parent function up or down, and the h translates it left or right. So here, if h is positive, means it moves to the right. When h is negative, it goes to the left. And then when k is positive, it goes up. When k is negative, it goes downward. And then reflections, if a is positive, it opens upward. If a is negative, it opens downward. And then when the absolute value of a is greater than 1, you have a stretch vertically. And if the absolute value of a is less than 1 but greater than 0, it's compressed vertically. So we're going to describe how the graph changes from the parent function. So this means it's going to go to the right 1. This means down 2. -3 is on the outside, so this is a vertical. Absolute value of -3 is 3, which is a vertical stretch. And there's a negative, so it's reflected. affecting the y, so it's reflected across or over the x-axis. Next, we're going to describe the transformation here and then graph it. So this x plus 2 means it goes left 2, plus 4 means up 4, the negative on the outside means there's a reflection over x-axis. There is no dilation on this one. So if I graph this one, normally I have it at 0, 0, and then the 1 squared is 1, 2 be 4, 1, 2, 3, 4. So here's the parent function. Now it's saying move the vertex through the left 2 and then up 4. So left 2, 1, 2, up 4, 1, 2, 3, 4. So here's our vertex, and then it's reflected. So now if I let's just put a number in for x. So I'm going to put -1 in for x. -1 plus 2, and I square it, and then add 4. -1 plus 2 is 1. 1 squared is 1. Times -1 is -1 plus 4 gives us 3. So I have -1, 3 should be here. It means here, so graph would look something like that. Next, describe the graph of g of x equaling 1/3 times x plus 4 squared minus 1 is related to the parent function. So it went left 4, down 1, and it's a vertical because vertical dilations because it's outside the parentheses. It's a vertical compression because it's less than 1. There is no reflection because I don't have any negatives involved. And example 6, although they may appear flat, properly designed football fields arc to allow water to drain. Fields rise from each side to the center of the field, known as the crown, which should be between 1 and 1.5 feet in height. A cross section of the football field that is 160 feet wide and has a 1.5 foot crown can be modeled by g of x equaling -0.000234 times parentheses x minus 80 and parentheses squared plus 1.5, where g of x is the height of the field and x is the distance from the sideline in feet. Describe how the g of x is related to the graph of f of x equaling x squared. So this means 80 to the right. 1.5 means 1.5 up. And then this tells us that it's on the outside, so this is a vertical. Less than 1, so it's vertical compression. And there's a reflection over the x-axis. Last one says, Grand Jete is a type of ballet leap in which a dancer starts on one leg and performs a split in mid-air and then lands on the other leg. It is designed to make a dancer appear as if they are floating through air, while their center of gravity follows a path that can be modeled by a quadratic function, where g of x is the vertical distance in feet of center of gravity from the starting point, and x is the horizontal distance in feet. Describe how g of x is related to the graph of f of x equaling x squared. You need to identify the a, h, and k, and then describe the transformation. So our a in this example is -0.17. Our h in this case is 3, and our k here is 1.53. If we were to describe the transformation, this would be to the right 3, up 1.53. This would be a vertical compression, and we reflect over the x-axis. So that is our lesson on transformations of quadratic functions.